Hello, hello. Right. Okay. Now, last week we started with this already, right? Yeah. Remember ions? Yes. Okay. Now, today we're going to do negative ions. So, remember all positive ions must be metal ions. Okay. Group 1 release 1 electron. Group 2 release 2 electron. Group 3 release 3 electrons. Now we're going to do negative ions. Okay. So negative ions for your level, you only need to focus on 3. The 3 you need to focus on is group 5, 6, 7. That's all you need to focus on. Group 5 will have how many valence electron? Group 5 will have 5 valence electrons. So how many electrons do they need to receive? They will receive 3 electrons. So everybody in group 5 will form negative 3 because you receive 3. Negative electrons are negative. Group 6, they will receive 2 electrons. So everybody in group 6 will be negative 2. Group 7 will receive 1 electron. So it will be negative 1. Okay, so negative 3, negative 2, negative 1. Can? Okay. So, for example, a fluoride ion. So if you need to remember that fluorine will become fluoride. Chlorine will become chloride. So let's start with fluorine. Fluorine, the element is 2, 7, correct? The element starts with 2, 7. In order to achieve full outer shell, it becomes 2, 8. So fluorine, 2. Okay. First of all, you need to remember 1, 2, 3, 4, 5, 6, 7. The eighth one comes from somebody else. So when you draw, you have to draw it different shape to show that this came from somebody else. This came from the metal. So then you bracket negative. Okay, so sometimes you no need to draw the inside one. They will tell you what to draw lah. Okay, so if it's chloride ion, chlorine is 287. Same, right? 7. So how many electrons will it receive? Also 1. So chlorine. So I'm going to draw inside lah 2, 8, but I draw 7 lah. So let's say I draw 1, 2, 3, 4, 5, 6, 7. Again, it must show the 8, 1 comes from somebody else, and this is a negative 1. So from 287, it becomes 288. Get it? Okay. Please draw these two and try and draw the other 3 negative ions. You can look at the periodic table to find the electron arrangement, okay, Jonathan? Okay, can?
Yeah.
All right, so oxide. So you must always remember oxide starts from oxygen. Oxygen is 2,6. So it will become oxide O2 negative 2,8. Okay, so you can draw the inside one if you want. 2,8. So look at this. 1, 2, 3, 4, 5, 6, 7, 8. Or you can do the other way around, but make sure the two electrons are different from the rest. Okay? So it's 2 negative. You don't have to draw the inner shell. I'm just showing you lah. So sulfide starts from sulfur. Sulfur is 2, 8, 6. So I'm just going to draw the outer shell. So same thing. 1, 2, 3, 4, 5, 6, 7, 8. Like that. And it's 2 negative like this. Okay? So this is a sulfide ion. Do you know why? Because 2 negative will receive 2 electrons. It's 6. It needs 2 more to achieve full outer shell. Okay. Nitride comes from nitrogen. Nitrogen is 2, 5. So how many will it receive? 3. All right. So nitrogen from 2, 5 become 2, 8. Look at this, 1, 2, 3, 4, 5, 6, 7, 8. 3 negative, like that. Can you understand? Get it? Okay. Jai, okay? You understand? Jonathan, okay? You did that? All right. So remember summary. Group one, positive one. Group two, positive two. Group three, positive three. Group four, nothing. Group five, negative three. Group six, negative two. Group seven, negative one. IGs will only ask you this. It will only ask you this for ionic. Okay, so only the three groups for metals and these three groups for non-metals that you need to remember. Okay, they won't ask you beyond this. Okay, so you just have to remember 1, 2, 3, 5, 6, 7. That's it. Can I? Okay, so in that case, if the metal releases the electron and the non-metal receives the electron, then they combine together to form an ionic compound. So let's look at ionic compound. So when we look at this, it's sodium and chlorine. So sodium 281, chlorine 287. So this one will give out this electron to this guy. Correct? Okay. So this guy will become Na, release one, positive one. Cl, receive one, negative one. So Na, okay, now if you are required to draw the inner shells, remember this, huh? In exams, sometimes they will ask you to draw the inner shell, sometimes they won't. Always be careful what the question says. So from 281, it now is 28. And it is a positive ion. And from 287 now, it's a 2, 8, 8. And remember the 1, 2, 3, 4, 5, 6, 7. The 8 one must show clearly that's from there. And the whole thing is a negative ion. So one positive ion and one negative ion combine together to form the ionic compound NaCl. Get it? And this is the dot and cross diagram. Okay? Can you please try the dot and cross diagram for number 2 and number 3? Try and see. Okay? If it needs more than one, you no need to draw two lines. Just draw one positive, one negative next to each other, and then just write down the formula. Draw the shell reaction. Yeah, just draw the shell of it. Remember exam draw with pencil, ah? Okay, you guys done with this one? Yeah. Okay, so you must always view lithium 21, sulfur 286. Okay, so lithium basically from 21 becomes 2 lah. Okay, so left only 2 electrons and it's positive 1. Right? Correct? Okay. Now sulfur, no need to draw everything lah. 2, 8, no need to draw lah. Okay, but it gives 6, remember 1, 2, 3, 4, 5, 6. There's 2 of it. So this is very strange. If this one is 2 negative, how can it combine together? So what happens is lithium can only give out 1, but sulfur needs 2. So you will have 2 lithiums each giving 1 electron. Make sense? So then here is 1 positive, here is 2 negative. Your formula for lithium sulfide is Li2S. Now exam, sometimes they will draw 2 lithium for you. Okay, so sometimes if it's like this, they will draw 2 lithium for you like that. Okay? Alright, for now, no need lah. But this is how lithium sulfide looks like. Make sense? Okay? So the ionic formula is Li2S. Okay. Have you completed these two? These three? No. Okay, can you try? Can you try? For drawing the ion, you just draw one positive, one negative, but you need to write down the formula like that. If it's Li2S, you write Li2S. Okay. Jonathan, have? Jerry, you okay? No, okay? The first few chapters are not very difficult, so I won't like no need to no need to hold your hand and draw for you. Like it's quite simple the first few chapters. Okay. Okay. Can I discuss? Can I? Okay, so let's look at this. Always remember to write down the electron arrangement. Okay, because sometimes it looks very simple. It looks very, very simple, but you need to write down electron arrangements. For example, magnesium is 282. So if I write like this, if I write like this, hello. Hello. Guys, do you watch the video or not? Like the videos that I upload because you missed half the lesson. Huh? Magnesium is a metal. 282. Metals always, 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 forever and ever release electron. So from 282, it becomes 28. This kind of equation is called what? This is called a half equation. Okay? Oxygen, oxygen is 2,6. It receives 2 electrons to become O2 negative 2,8. Okay? However, oxygen exists as a single oxygen or O2. O2. So it's O2, so it's 4 electrons, so it's 2 O2 negative. Okay? So in order to draw the dot and cross diagram, magnesium from 282 becomes 28. Okay, so this is the dot and dot cross diagram for magnesium. And oxygen, 2, okay, this one you must be very, very careful. 1, 2, 3, 4, 5, and 6, 7, and 8 come from over here. So you must be able to draw like that. 2 negative. Okay? So magnesium oxide is MgO. That is the formula. Okay? Got it? Okay. Have you guys finished the last two? Yes. Jen? Okay, okay, do last one first. I give you a favor, the last one. Okay, boys, this is the one from last week. This one, formation of ions. Okay, you can copy. I put it downstairs for you. Did you take? Um, or someone is supposed to pass to you. Jia Yi was supposed to pass to you. Does your band actually finish?
No.
You are orchestra or band? Band. Orchestra. Eugene, orchestra or band?
Not no.
No, none. Just woke up late.
Silence.
Eugene not in school.
Yes.
What school are you in? You're in someone's school. You're not here. I thought your brothers were here. But you didn't come here. How come?
Uh, in the statistical exam, I was sick, so I didn't do well.
Oh.
So, not very far.
Oh, okay, okay. So you go Saman,
So, not very.
but not Peralihan lah. Oh, okay, okay, okay. I thought you went to school. Are you the last one already? Are you the last brother? There's another one. How many of you? Four. Isam, and then after that,
Yeah.
Ian, you, and then got another one. The last one is what? Huh? Sorry? E what? Ishe. How old is he? Oh. Four boys. Your mother must be so tired. Okay. Don't have, is it?
Okay, let's sit down.
You were here last week, right? I passed to you, right? No, not that one, not that one. It's not this one. No, but see. Formation of ionic. Ah, there's the page. Ah.
Right. See?
Okay, can follow? Okay, can I continue? Can I continue? Yeah? Alright. Okay, Jay, can ready? Okay. So aluminium, Al is 283. So it will become Al3 positive. So it will look like this. 2, 8, 1, 2, 3, 4, 5, 6, 7, 8. So the 3 has been released. From 283 become 28 because 8 is a full outer shell. So it's 3 positive. Release 3 electron is 3 positive. Okay? Nitride is from nitrogen. Nitrogen is 2, 5. It needs to receive 3 electron to become N3 negative. So just nice, huh? From 2, 5, they become 2. So original is 5. 1, 2, 3, 4, 5. This is original. 3 comes from here. So it's 3 like that. So the formula for aluminium nitride is ALN. Okay, last one, calcium fluoride. So always write down the electron arrangement. Don't depend on your brain power. So calcium from 288 it becomes Ca2 plus, release 2 electron, 288. Okay? So I'm very lazy to draw 288. I'm just going to draw like that. 2 positive. Okay? Fluoride, fluorine is 2,7. It receives 1 electron to become 2,8. So fluorine will be 2, 1, 2, 3, 4, 5, 6, 7. The eighth one comes from the other side. But teacher, like that, not balanced. Of course not balanced. Calcium releases 2, but fluorine only receives 1. So how? Calcium gives 1 to 1 fluorine. Each fluorine takes 1. So the formula would be CaF2, 2 fluorines, 1 calcium. Make sense? Okay. Jay, you got it? Okay. All right. Okay. Now, yeah. What is it? Oh, oh, you're not done. Oh, okay, okay, okay. Sorry, sorry, sorry. Okay. Now, so you understand the concept of ionic. Ionic, it must be a metal that becomes positive and a non-metal that becomes negative. Okay? So for example, NaCl. But then you see, it's not just one Na and one Cl. So for example, this one, right? This is positive. Next to every positive, there's a negative. Next to every negative, there's a positive. It forms a lattice arrangement. A lattice arrangement means a regular arrangement. It just goes on and on and on and on and on. Okay. Now, every single positive and every single negative is held together by these attractive forces. And this attractive forces is known as electrostatic. Electrostatic forces of attraction. The reason why it's called electrostatic forces of attraction is because it's attraction forces between positive and negative ions. Okay? Positive and negative ions. Okay, now, do you think electrostatic force of attraction is strong or weak? Okay, so electrostatic force of attraction is very, very strong. And not only it's very, very strong, it's many, 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 many bonds. So because of that, the melting point and boiling point would be very, very high. It would take a lot of energy to break it apart. So that's why the melting point and boiling point is high because there is very strong ionic bonds or very strong electrostatic force attraction between oppositely charged ions. Oppositely charged ions means between the positive and negative. It's basically, if I just put glue between two pieces of paper, it's just two pieces of paper. But if I put glue between 1,000 pieces of paper, that book is all stuck together. It's super, super, super strong. Can you understand? So that's what happens in sodium chloride. Okay, now, do you understand the concept of conduct electricity? Only two things can conduct electricity. In order to conduct electricity, it has to be a charged particle. That means it either has to be an ion or an electron. But not enough if it's an ion or an electron. It has to be a free moving ion or a free moving electron. Only these two things can conduct electricity. So when an ionic compound is in solid, the ions are not moving. So if the ions are not moving, do you think it can conduct electricity? No, cannot. So it does not conduct. But when the ionic compound is in aqueous or molten, aqueous means dissolved in water. Molten means melted. When it's melted, do you think the ions are freely moving? Yes. So free ions, therefore it can conduct electricity. All right, so this is the two most common questions that they ask you. And this is known as physical property of ionic compound. Okay, why does the ionic compound conduct electricity? Because it has free moving ions in molten and in aqueous. Why doesn't it conduct electricity in solid? The ions are not moving. Remember, ionic is ions. Please don't go and say ionic is electrons. It's like telling me orange juice got made of what? Orange juice made of apples. Wait, right? Orange juice is made from orange. So ionic is ions. Okay? Can I understand or not? Okay. Okay, ready? Guys, do you understand? Is it very difficult? No, right? Okay, it's very simple, right? Okay, now, let's try this. Can you try this question? Question B. So just now we were doing practice. This is how a exam paper asks you. Okay, this is how they ask you in exam. Okay, can so can you try this page, please? This page. Just the first page only. Just this page only. Okay? Try and answer this page. You can refer to your periodic table. Okay. Ariel, you want me to show you the past notes or you want to try this question? Past notes, is that? Here, today we started from here. Last week's one you didn't copy. Okay. Scroll down. Scroll down. Are you done? Must tell me lah. I cannot read your mind.
Kindness. English.
Okay.
So,
Sorry? Eugene, focus, Eugene. Hmm?
it's gone. The 3 minutes gone.
Zoom in.
And then without any. No,
This one.
no, no.
This one.
Yeah.
Okay.
Thanks.
Okay, done?
Yes.
Ready? Okay. Guys, I know this is a lot of new stuff to some of you, but you have to up your game. Okay? Because I already told you we don't have much time. We have enough time, but the time that we have, you need to focus. Okay? And you need to know, like, don't be late. Okay. Try. Okay, I know your orchestra is actually, what is the finishing time of orchestra?
12 half.
12. 12:30.
12 half. Or 6 or half.
Then you must go home and watch the videos lah. You cannot like this one also you want that one, this one, then don't do anything. Okay, all right. Now you can copy later. Let me finish this first, okay? Okay. So sodium is Na. Metals are always alone, 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 alone. Fluorine is F2. Okay, so the formula is NaF. We balance the equation 2, 2, like that. Okay? Okay. Sodium, you must know the electron arrangement. Sodium, okay, so you see, sodium is 281. You already wrote 2 here. So you have to draw 2, 8. Don't go and put the 1 because it already released the electron, so it's positive 1. You write positive or positive 1 is the same thing. Fluorine from 2, 7, it becomes 2, 8. So 1, 2, 3, 4, 5, 6, 7. The 8th one comes from here. You must be very clear on that. The 8th one comes from here and it's a negative charge. Okay? Alright. Lithium and nitrogen. Lithium is Li. Metals are always, 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 always and forever alone. Nitrogen is N or N2? N2. Remember the list. Fluorine, chlorine, bromine, iodine, nitrogen, hydrogen, oxygen. Jerry, go back and watch the video.
Okay.
Okay. Alright, what is the formula for lithium nitride? Li3N. Okay, I'm going to teach you a little bit about balancing equation. This is last week's notes. Okay? So, how do you balance equation? Like this. Here you see, it's basically LCM. You learned LCM before, right? Okay? So here got 2 nitrogen, here got only 1. Put another 2 in front. Okay? Here got 6 nitrogen. That's it. Okay. Again, nitrogen is 2, 5. When it forms a charge, it becomes 2, 8. So here's already 2, so 8. 1, 2, 3, 4, 5, 6. Sorry. 1, 2, 3, 4, 5. Or 6, 7, 8. Okay? Make sense now? Is it making sense now? Kind of. Jai, get it? Ijin, okay? Alright. Jonathan, okay? Alright. Now, okay, this one I want you to do as homework, This one do as homework. Okay? Sorry? Which one, which one, which one? For which one? Yeah, oxygen, right? O2. So this is a list that it exists as molecules. Okay.
What's one other building?
Iodine.
Oh. Oh.
Okay, so Jaren, go back and finish this, the one on the board. I'll send you the notes. Okay, each person take one of this. So this is ionic. Okay, this is ionic. It's between metal and non-metal. Today we're going to start another one. It's called covalent. Everybody got?
Yeah.
So just now what we learned was ionic. Okay, so we just recap quickly. So what we learned previously was ionic. It was between a metal and a non-metal. The metal will release the electron to become a positive ion. The non-metal will receive an electron to become a negative ion. The positive and negative ion then combine together with electrostatic forces of attraction to become an ionic compound. So that is previously ionic compound. Now we're going to the second type called covalent. Covalent in IGs you learn two types. One is called simple molecular and another one is called giant. So we're going to focus on the simple molecular first. Covalent is between non-metals only. It's only between non-metals. So the definition of covalent is covalent compounds are formed when pairs of electrons are shared between atoms. And it must, only, ever, forever and ever, non-metal. Okay? Okay, now all of these fellas, why do they want to go and become a bond? They are all trying to achieve full outer shell. They're all trying to achieve full outer shell. Nobody does this for fun. They all just want to achieve full outer shell. Okay? So if it's only one shell they want to achieve, okay, so for example, hydrogen. Are you guys done with this? Are you guys done with all of this?
Yeah.
Done, Okay. So, all right. Hydrogen. If anything I teach is too fast or you missed out or you were in the toilet, please watch video. That's why I record the video, not for fun. Okay. Hydrogen has how many electrons? Just one. Hydrogen just has one. So one. This other hydrogen has how many? Also one. So this hydrogen tells this hydrogen, give me lah, give me lah. Then this hydrogen tells them, no, you give me, no, you give me, no, you give me. So they move closer and closer and closer and closer together, and then suddenly they join together. And then this hydrogen, okay, so they're not very smart lah. So this hydrogen says, hey, I got two, yay! And then this hydrogen says, hey, I got two, yay! But actually, they are sharing it. So you can draw like this, or it can be like this. Okay, but don't draw like this. Why? Why is this one wrong?
Will you not share it?
It's not sharing, both are on one. So These two, I prefer you draw this one. This one is better, can see clearer and you won't forget. So does each hydrogen have a full outer shell now? Yes, because remember for one shell is only two. So they're both happy already lah. Yay. So they form a single covalent bond. When we want to draw, we draw it like this. So this is a dot and cross. This thing that we just drew is dot and cross. This thing represents a pair of electrons shared. So it represents a single covalent bond like that. Okay, so this represents this. When you draw it out like this is called a dot and cross diagram. Okay, dot and cross diagram. This one is called a displayed formula. So remember just now I was teaching you hydrogen exists as what? Hydrogen exists as H2. And this is the reason why hydrogen exists as H2, because uh, H is not stable. It will want to achieve a full outer shell with somebody else. Get it? Can you understand?
Yeah.
Alright. Okay. Chlorine. Can you all please go and look at your periodic table and find me the electron arrangement for chlorine?
287.
287. So chlorine is 287. So the outer shell got how many? 7. How many more does it need to achieve full outer shell? 1 more. So what does it form? How many bonds? 1 lah. So this chlorine, one chlorine says to another chlorine, I only draw the outer shell lah. You have 7. 1, 2, 3, 4, 5, 6, 7. You also have 7. We share lah. We share. Okay. Now, do both chlorines now think they have 8? Yeah, because they're not very smart. So this one also single covalent lah. Like that. So this bond is this bond. Okay?
And when you find that electron,
Electron arrangements on the periodic table. Chlorine is 17, so you need to write down. Can you see periodic table? Chlorine is 17. Remember the first class I taught you 281, 282, 283? So 287 because 2 plus 8 plus 7 is 17. Ah. Hey guys, all the old videos I never take down, I never delete, okay? Please go and watch when you're free if you don't understand. Okay,
what's the CL dash CL?
that's displayed formula. Displayed. 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 Okay, we're almost done. We're almost done. All right. Chem. Okay, water. Hydrogen. How many bonds does it need? 1. Oxygen. What's the electron arrangement? 2. 2. No, it has. Look at the periodic table. OMG. How many protons does it have? 2, 6. Thank you. Did you watch? It's because it has 8 one. 8 is 2, 6 lah. Did you all watch Project Hail Mary?
Yeah. What's that? Of course.
It's the coolest show. The show. Okay, so because it is 2, 6, what is the valence electron? 6. How many electrons does it need to achieve full outer shell? 2. So if you need 2, you will form 2 bonds. So oxygen needs 2. Hydrogen needs how many more to achieve full outer shell?
One.
One! It has only one shell. Remember, it's two. The first shell only maximum two. So hydrogen only needs one bond. So every hydrogen needs one bond. Every oxygen needs two bonds. So water looks like this. Without water, we will all die. H2O. Each hydrogen only needs one electron more. Hydrogen has how many? 2, 6. 1, 2, 3, 4, 5, 6. This is how water looks like. This is why we all don't die.
Wow. Wow.
It's so important, right?
Yes.
Okay. What is the electron? Wait. Focus, focus, focus. Lit, ready, don't talk. What is the electron arrangement of carbon? 2, 2, 4. What is the electron arrangement of hydrogen? 1. How many bonds does carbon need? How many more does it need? 4. Very good. How many does hydrogen need? 1. So it will look like this. CH4. Only draw the outer shell. Each carbon needs to share one. Each hydrogen shares. Can you try and draw this? Only draw the outer shell. Draw the dot across. Okay? No. Try, try, try. Okay, ready? Okay, so it will look like this. Carbon in the middle. 1, 2, 3, 4. Hydrogen, 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 hydrogen. 1, 2, 3, 4. 1, 1, 1, 1. Is everybody happy? Everybody achieved full outer shell? Yes. Do you get it? So that's why methane is CH4. This is called a covalent molecule. Okay? Now, each carbon and hydrogen, how many electrons are shared? How many pairs? One pair. One pair is a single bond. Each pair, like that, one line is a single bond. Okay? Do you understand?
Yeah.
Yeah? Alright. Okay. Make sense?
Yes.
Okay, what I'm going to do is we're going to do 2 rings of 8. What is 2 rings of 8?
Oxygen.
Oxygen. Okay, I didn't draw it here. You just draw it wherever you want. Okay, this one later. I have to show you one by one. Okay, let's do it down here. Oxygen. Okay, so oxygen exists as O2. Oxygen is 2, 6, 8. Total is 8. So in order for oxygen to achieve full outer shell, how many electrons does it need? 2. So each oxygen forms two bonds with another oxygen. So that means it cannot form a single bond. It forms a double bond. Single bond shares one pair. Double bond shares two pairs. So it will look like this, a little bit different. So this oxygen has 1, 2, 3, 4, 5, 6. But this oxygen will have 1, 2, 3, 4, 5, 6. Can you see how there's two pairs inside here? 4 electrons in the middle. So this is called a double bond, a double covalent bond. Okay? Now, please watch the videos